This video covers combustion analysis part 2. What we're going to be starting this time is with a 10-gram sample of our hydrocarbon, which this time has oxygen in it. And we're going to be reacting it with excess oxygen. We get out 9.78 grams of CO2 and 1.97 grams of water. So the first thing we're going to do is we'll calculate the moles of carbon based on CO2. Then we'll calculate the moles of hydrogen based on the water. And then we're going to take those calculations and calculate the grams of oxygen using the law of conservation of mass. So let's go ahead and do that first. We're going to calculate the moles of carbon based on CO2. I've calculated the moles of carbon based on the grams of CO2, so this is a stoichiometry problem I've solved here. So here we have 0.2222 moles of carbon. I've done the same thing with hydrogen. Here, though, I've taken a new shortcut. I have 1.97 grams of hydrogen, and we have 18.016 grams of hydrogen of water in the denominator. This is a true statement. We do have 2 moles of hydrogen for every 18.016 grams of water, so a little quicker on working out the math here. So we end up with 0.2187 moles of hydrogen. Now, somehow we have to get to the grams of oxygen using the law of conservation of mass. We know we have 10 grams of this material here. 0.2222 moles of it is carbon, and 0.2187 of it is the hydrogen. So we're going to convert these to grams. So let's go ahead and do that. So this is times 12.01 grams per mole. And we do that, we get 2.67 grams of carbon. And we're going to multiply this by the molar mass of hydrogen. And we have 0.2204 grams of hydrogen. So we know that we've got 10 grams of our original compound. That's from up here. We're going to subtract the amount that's due from the carbon and from the hydrogen. And we end up with 7.11 grams of oxygen. Notice it's just O, it's not O2, because we're not talking about the diatomic right here. It's incorporated into a molecule. All right, now we're going to take our 7.11 grams of oxygen and convert it into moles of oxygen. And that is 0.444 moles of oxygen. We're ready to write out our formula. We have carbon, and coming back up here, we're going to use this, 0.2222. We have our hydrogen, that one right there, 0.2187, and then we have our oxygen, 0.444. If we divide through by the smallest, and we take into account that there will be a little bit of experimental error, we end up with an empirical formula of CHO2. Now, if we had the molar mass, we could figure out whether instead it might be C2H2O4. But right now, all we know is that this is our empirical formula.